Welcome, guys, to another wonderful episode with me, Makafuya Heto, on this channel. Thank you for all the support. We are treating more problems in probability, and if you are new here, please like, subscribe to receive more notifications when new videos are uploaded every week. Now, today we want to continue with our problems in basic probability. And this is another problem for us this week. We will go through the problem accordingly and see how we are able to use probability theory in solving real life problems like this. Okay, so please stay tuned. Welcome back, guys. In this problem, we are told that in modeling the number of claims filed by an individual under an automobile policy during a 3-year period, an actuary makes the simplifying assumption that for all integers n greater than or equal to 0, p of n plus 1 equals 0.2 p of n, where p of n represents the probability that the policyholder files n claims during the period. Under this assumption, we are told to calculate the probability that the policyholder files more than one claim during the period. So our model says that for any n greater than or equal to 0, p of n plus 1 equals 0.2 p of n. So we jump on to solve our problem. So from our model, we are told p of n plus 1 equals 0.2 p of n for n greater than or equal to 0, where n is an integer. So we have numbers n equals 0, 1, 2, and onwards. So to help us better visualize this, let's pick the first set of numbers and see how best we can find a pattern in this model. Okay, so we know p of 0 is still p of 0, which is the first value in this. We know that p of 1, right, 1 then becomes 0.2 p of 0, that you agree with. P of 2 becomes 0.2 p of 1, which is the same as 0.2 squared p of 0, because we know here that p of 1 is 0.2 p of 0. Okay, so the same happens with p of 3, and that gives us 0.2 p of 2. It then becomes 0.2 cubed p of 0. So we can say more generally, right, as we move on and on and on, we have p of n to be 0.2 to the power n p of 0, right? Now, we all know that if we sum across all values, say x, of the probability of x, then we have 1 to be our answer. So the sum across all values in the interval of p of x is 1. So to help us do this, I would sum across all the values. I'll sum across all the values of n. I'll sum across all the values of n from 0 to infinity of 0.2 to the power n p of 0, right? And this should be equal to 1. Okay, so it implies that p of 0 is a constant, right? And we have sum from n equals 0 to infinity of 0.2 to the power n, and this should be equal to 1. Now, with this, we know we can have this sum here, for any values, right? Any value here, a to the power n, this is 1 over 1 minus a when a is less than, is between, when a is between 0 and 1. So with this, we see that our a here is 0.2. So we can say that probability of 0 times 1 over 1 minus 0.2 should be equal to 1. And this implies that p of 0 equals 1 minus 0.2, which is 0.8. Now, we're told to find the probability that the number of claims we have is greater than at least one claim is being observed, is greater than or equal to 1. And this is the same as 1 minus p of n less than 1. And we know the only value which is less than 1 is p of n being 0. And this is 1 minus 0.8, which gives us 0.2 as an answer. This here is from, this value here is from our knowledge geometric progressions. Right, so this helps us. So our answer here is 0.2, and we're told to calculate the probability that the policyholder files more than one claim during the period. It's more than one claim, not greater than or equal to. So we have more than one claim being made. More than one claim being made. So it's probability that n is greater than 1, which is 1 minus the probability that n is less than or equal to 1. So you agree with me, this is 1 minus probability of n equal to 0 plus probability that n equals 1, right? And this is 1 minus 0.8 plus 0.2 times 0.8 that we know. And this is 1 minus 0.8 plus 0.16, right? And this here gives us 1 minus 0.96, and our answer is 0.04, right? So our answer choice is answer choice A. It's an answer choice A, that our answer. So the probability that more than one claim will be filed during the period is 0.1. So we'll look at another question on the probability theory and see how best we can use our knowledge in probability to work out these problems. Please stay tuned. Welcome back, guys. This is the second problem we'll be looking at today, and it still uses simple probability theory. In this problem, we are told an insurer offers a health plan to the employees of a large company. As part of this plan, the individual employees may choose exactly two of the supplementary coverages A, B, and C, or they may choose no supplementary coverage, right? The proportions of the company's employees that choose coverages A, B, and C are 1 over 4, 1 over 3, and 5 over 12 respectively. We are told to calculate the probability that a randomly chosen employee will choose no supplementary coverage. So we jump on to solve the problem. Okay, so we are told there are three coverages, right? Let A, right, be coverage A, right? Let B be coverage B, C be coverage C, and S be no coverage, right? Now, our problem tells us that for every employee, the employee chooses exactly two coverages or decides not to choose any coverage. Now, our problem here is telling us that employees choosing coverage A is 1 over 4. Now, thinking of this, no employee is going to choose just one coverage. They are going to choose exactly two coverages. So if we are told the probability that he chose A is 1 over 4, and it indicates that he either chooses A and B, or chooses A and C only. So that probability 1 on 4, you'll bear with me here, would be probability that A intersection B intersection C complement plus probability of A intersection C intersection B complement, which is equal to 1 over 4. Right. Now we'll do same for the next two, because we are told employees choose exactly two of the supplementary coverages. So if he's choosing B, then it's either he's choosing B and A and not C, or choosing B and C and not A, and that gives us 1 over 3. The same applies for C, which is probability of choosing C and A and not B, plus probability of choosing C and B and not A, and that is 5 over 12. We agree with that. Now, we know that the sum of this whole probability, right, this whole set of probability should, plus the probability that you choose no coverage, will give us 1. Okay, so here we know that when we sum these three items up, right, we notice here that this probability here, this probability we have here, is the same probability we have here, right? We use another color. This probability we have here is the same as the probability we have here, and the probability we have here is the same probability let me use another color. It's the same probability, this probability here is the same probability we have here. So interestingly, when we sum all these three units up, we have 2 times of each one of these C plus probability of B intersection A intersection C complement plus probability of A intersection C intersection B intersection C intersection A complement, and that should be equal to 1 over 4 plus 1 over 3 plus 5 over 12 when I add these 3 units up, and they should give me 1, right? So I have probability of C intersection A intersection B complement plus probability of B intersection A intersection C complement plus probability of B intersection C intersection A complement being equal to 1 over 2. Now, we know that this probability sum here, right, this sum here, probability of C intersection A intersection B complement plus probability of B intersection A intersection C complement plus probability of B intersection C intersection A complement plus the probability of choosing no coverage should be equal to 1, right? Because here we are saying he that chooses C and A and not B, he that chooses B and A and not C, he that chooses B and C and not A, or he chooses the fact that he won't get any coverage from him or herself. We know that this probability here, right, is 1 over 2. Is 1 over 2, right? So we can say that 1 over 2 plus P of S equals 1, which implies that P of S equals 1 over 2. So we can see that the probability of not choosing a coverage is 1 over 2, which is our answer, choice C. Alright guys, thank you so much for staying with me in this session. In the next session, we will treat other problems which are tested in the exam P, and I would like you all to always support the channel by subscribing. Thank you so much. Bye bye.